Okay, so what we're going to take a look at now, sorry this thing's not focusing, is we're going to take a look at what actually happens when you find the inverse of an exponential or a logarithmic equation. So remember, to find an inverse, you switch the x and y. So literally on your paper, you switch where the x and y are, and then you try to solve for y. So you add 7 on this one, gives you 2 to the y plus 1 power. Then you get this y plus 1, it's in an exponent. Well, that's where that knowledge of the fact that these things are inverses of each other comes in handy. And knowing that definition, how to rewrite from one form to another. So if I'm looking at this and I got to get this exponent out of the exponent, I want to do a logarithm. Or, in other words, I want to write this in logarithmic form. So I want to say the log base 2, because that's the base here, of x plus 7 equals y plus 1. This base raised to this exponent equals this. Isn't that exactly what that says? Yes, it is. 2 to the y plus 1 equals x plus 7. It's right there. So just using our definition, then we can get y by itself by subtracting the 1 over. And so now here is our inverse. We can do the same thing by taking a logarithm and getting the inverse of it. Switch the x and y. And then solve for y. But again, all of this stuff's in the logarithm. We got to get it out. So now we go the other way. Instead of taking it from exponential form to logarithmic like we did on the last problem, we're going to go from logarithmic to exponential. But it's still just using the definition. This base raised to this exponent equals this stuff. So 3 to the x equals y plus 2. And then all I got to do is subtract my 2. And there you go. There's your inverse.